This is the homework for 550 and 551. In 550, you need to graph the lines y equals 2x minus 3 and y equals 2x plus 1. In part A, you need to determine where do these lines intersect. So to graph these lines, the first one, the starting point or the y-intercept is at -3, and the growth rate or the slope is 2 over 1. So you rise 2 over 1. Positive 2 on the y, positive 1 on the x. Rise 2, run 1. And that's at a constant rate. So forever, it will be rise 2, run 1. For the second equation, the y-intercept or the starting value is at positive 1. And its rate of change or slope is positive 2, 1, 2, over 1, positive 2 over 1. So if you notice that both of them have the same growth rate, so if they have the same growth rate, it will always be rising 2, running 1. And same with this one. Well, if that's true, you can see that these two will never intersect because they are parallel lines. This forever will go at this growth rate, and this one will forever go at that growth rate. And they're both growing at the same rate, but they have different y-intercepts. So they'll never intersect. They're parallel lines. Part B is telling me to solve the system using the equal values method. On the equals value method, I have the two equations that we just graphed, y equals 2x minus 3 and y equals 2x plus 1. And if this is what y equals, 2x minus 3, I can take that and substitute it into here because it's saying y equals this. So if y equals 2x minus 3, I can plug it in here. So I take y and put 2x minus 3 and then equals 2x plus 1, and I have it there. Now I solve for x. And I'm going to do inverse property of addition, which is subtraction. So I'm going to subtract 2x from both sides. That creates a 0 pair. That creates a 0 pair. And I'm left with -3 equals 1. Well, that's not true. So there's no solution. So if you get no solution, we can go back to our graph here. Well, they're parallel lines. A solution would be the point where they intersect. And if they don't intersect, they have no solution. And this is what it looks like when you solve it algebraically. In part C, it says explain how your graph and algebraic solution relate to each other. Well, there's parallel lines. They do not intersect, and there's no solution. So if there's no solution, that means that they're parallel lines. In problem 551, Janelle came up to bat 464 times in 131 games. So we have number of times at bat, number of games. 464 for every 131 games. At this rate, how many times should she expect to have at bat in a full season of 162 games? Well, how many times? We don't know how many times at bat, but we do know the number of games. And we're going to solve this by cross multiplying. So we have 131 multiplied by x is 130x. 464 multiplied by 162 is 75,168. Now we do inverse property of multiplication, which is division. We divide both sides by 131. 131 divided by 131 makes the giant 1. 1 multiplied by x is x. 7 75,168 divided by 131 is approximately 574. So Janelle would bat approximately 574 times in 162 games.